Yeah.
Right, I think there's another speaker coming up now, so I'm very sorry, but I'm going to have to leave you and go and join my family who are at the beach and waiting for me right now. Thank you so much for inviting me, and
Yeah.
I'll try to drop
Thank,
into a future meeting.
Liam, thank you
yeah.
very much for
Thank you, Liam.
joining.
Thank you so much.
Yeah.
Bye
Yeah.
bye.
Yeah, that was interesting. Bye.
Great. Exactly. We have another speaker coming up, and that is our well-known Travis Bemann, author of Zeptoforce, and he will talk about Zeptoscript, and we will learn about what a dynamic force language actually is. So, Travis, please go ahead.
Okay. Share my screen. Okay. I've got Zeptoscript loaded onto here. And as a recent addition, I have support for FAT32 file systems in the onboard flash of the Pico, in this case, the Pico W. So this nice little routine here we have is it calculates the first 25 Fibonacci numbers using coroutines. So yeah, compile it, then do like this, which is this is a very trivial test. And as you can see, it's using suspend and resume to generate the sequence of numbers for our nice friendly coroutine Fibonacci thing. And but anyways, the key aspects of Zeptoscript is that it tries to be as Forthy as it can be, or at least Zepto-Forthy as it can be, while providing dynamic typing and garbage collection. And because it's garbage collected, it can allocate anything it wants to a heap and you don't have to worry about it. Like for instance, here we are defining a what I call a cell sequence, which it's an array of values, but it's distinct from an array in that it is fixed size. It's a primitive in Zeptoscript, whereas arrays, which are resizable and all that, are built upon that. And then let's go and filter it so we only get even values. And then let's go and take the even values and add 1 to them. Get the map. And then we're going to iterate over it and print the values. So here we, through this little snippet of code, we get this. And as you can see, aside from this, which is a bit of syntactic sugar to make defining things like this easy, and syntax is definitely Forthy, but it allows you to do unforthy things like keep allocating sequences of values, filtering them to create new sequences, mapping them, and all that kind of stuff. And now I'm going to search the file system of, or not search, but list the file system of on this Pico here for a second program that I have, which this program is it's basically a implementation of an example from the pragmatic programmer, which when I was on vacation in June, I read the book during it, and I felt like I wanted to go and implement this example itself using actors, or at least the closest to an actor that I can make within Zeptoscript, which this is using Zeptoscript's multitasking functionality, which unlike Zepto-Forth multitasking, it's single, it's that it runs within a single Zepto-Forth task, but uses cooperative multitasking. But anyways, as we have here, we go and have code for implementing a number of different actors, like a waiter, like a customer, a waiter, a source of food, and an arbiter to control access to the sources of food so multiple orders don't stop on top of one another. And here we go and create an actor which basically take a execution token, which in Zeptoscript can be partially applied, in which such partial application I rely upon heavily. And it creates an unbounded channel for it, passes the unbounded channel to the passes execution token after forking, and then returns the unbounded channel to the caller. So let's go and compile our pi a la mode example. Now we're going to go and do pi a la mode test. And here's the output that shows everything it's doing here. Anyways, beyond examples like this, Zeptoscript supports things like a variety of different data structure types. Like, for instance, one type is a map. And with this map, we can go in, let's say, create a number of different values. This is what I call a generic map because it uses the there's a set of methods in the object orientation layer that are designed to be used for just about anything, such as converting them into strings or hashes or testing their equality. In a generic map, because you don't specify such words, it uses the default ones automatically. Now we're going to create a global and say my map, and then I'm going to go and add this map that we created to that. And then we go in we can print what's in the map, or we can, let's say, test for, we want to get bar. We can get that. Or another kind of data structure we support is sets, which are like maps, except for that they don't have key value pairs, they're just values. Oh, forgot to import set. And then we're going to go and iterate over the set. And it also supports, in addition to cell and byte sequences, and cell and byte slices, which a slice is basically, it's a range of a sequence, except for it doesn't, you can have multiple slices all point to the same underlying sequence. Let's say we have arrays, we have maps, we have sets, we have queues, which are used heavily by multitasking. We have coroutines. We have bit arrays, or bit sets more like. And all this, we go and have a language which in many ways is much richer than what can easily be done in Forth, because in Forth you're tied by the memory model. Where in the memory model you have to go and reallocate all your space for stuff. You can't, unless you are using a heap, which not all Forths have heaps, you can't go and say, hey, I want a foo now, and just have it magically appear. You have to plot how you're going to get memory for the foo and then tear it down if you're ever going to be done with it and all that. But because this is garbage collected, that's not an issue. So let's say we go and do our pile mode test, and then we're going to garbage collect it and then do heap free. And we're going to do run the test again. Each time it's creating a whole bunch of tasks and unbounded channels, but when we garbage collect it, in this case manually, and we get the free number of free values in the heap, it doesn't change because it's smart enough to say, hey, we aren't using this anymore, let's get rid of it all, without the user having to worry about, oh, how am I going to get rid of these tasks when I'm done with them, or anything of that sort. And this basically, how would I put it? You get all of this for free. Whereas, let's say this is not an application for Zeptoscript, but rather for Zepto4th. ZeptoEd, which is a text editor that I wrote. In ZeptoEd, I have to not just manually allocate all the space I need, but I have to also manually free it. And if I don't, there'll be memory leaks. which I have run into with it, which have been since been fixed. But in general, it's much more painful to do a lot of this stuff that you can do in this without even thinking in a Forth such as Zeptoforth for the reasons that I mentioned. So I think that Zeptoscript has quite a bit of potential. Still in its infancy stages. I haven't even made any releases for it yet because I still keep on changing lots of stuff around them. Like yesterday, I decided, hey, I don't want to go and use cell sequences in the form of records as the basis of my arrays, sets, and maps because it required a whole bunch of hackery to have words like show and hash and equal work with them properly. So I pulled it all apart and I reworked that so they would be their own data types underneath it all. Well, specifically, they'd be their own classes. And there is one thing I should mention is this has an object system, but it's not forced upon the user. But for some examples of how the object system works, here is an example of it. And as you can see, methods do not belong to any particular class. And also, classes do not have inheritance, unlike many OO systems. Rather, any class can implement any number of different methods. Essentially, they're duck types. And while classes can have members, like this one, those members are local to the class. They cannot be directly accessed outside of the class. And the idea is that if you want to expose them, you would write accessor methods for pulling the values out or setting the values on the objects. So like here we go and have each of these actually creates a pair of accessor words unto themselves that are only readable or usable from within this class, such as this, where we set it or we get it. And we also list the implementations for each of these within the class. The new method is a special one because when you declare a class, we go and get a make foobar word that's automatically created, which when called, it instantiates a member of that class and then calls this with that instance. Anyways, I've been probably all over the place here, and I've probably taken up a good amount of time, so I'm sending this over for any comments or questions.
Yeah, so thank you very much. And are there any questions to Travis?
I have one.
Yeah, Atlee.
That fork word that creates like a process thread thing, does it create a thread in the operating system, or is it something that you handle in your kernel?
Oh, I should have mentioned Zepto Forth runs in bare metal. But you could say that Zepto Forth is the operating system in this case, and fork does not create a Zepto Forth task. Rather, it creates a cooperative task within the Zeptoscript environment, which is distinct from Zepto Forth tasks because they're much more lightweight and they are implemented with continuations, actually. I actually borrowed the code for it from a similar multitasking system I'd implemented a while back in Scheme. I see Christian Hinsey has got his hand up.
Yes, I hope my microphone is working.
Yes.
I can hear you.
Okay. So I got stuck on one definition of a word, okay, when you started talking about Zeptoscript. And it's the definition of the word script itself. How is it different from any other programming language? What is a script?
Well, basically, in this case, when I originally created it, I had intended it for being able to extend programs that are written in Zepto Forth, hence Zeptoscript. Even though it's sort of taken a life of its own, and I haven't actually embedded it in any applications for Zepto Forth as of yet. So it's these days it's more of a standalone language that's layered on top of the Zepto Forth environment.
So Zeptoscript is essentially a kind of application written in Zepto 4.
Yes.
And this application has the purpose of simplifying programming by providing specialized word or more easier to use word, more or less.
Well, it provides a whole new language environment. And in many ways, it is much, I find it to be much simpler to work with than Zepto Forth. The only problem with it, though, is it's much more memory intensive, which is actually in many ways a result of a conscious design decision I made. Because in a different language that's for embedded systems, that's garbage collected, MicroPython, they have the problem of memory fragmentation, where like someone will make their weather station in MicroPython, and after running for a few weeks, it fails. And then they're wondering, hey, why did my weather station fail? Well, it kept on allocating and getting a garbage collecting memory until memory became so fragmented that it could no longer allocate more memory due to the fragmentation. And so the decision I made was to use Cheney's algorithm. It's simple, it's fast, it's the speed of garbage collection is determined by the size of the working set rather than the size of memory. The only cost it comes at is that half of your heap can be only used at a time, which is to me at least, a small price to pay, considering that Cheney's algorithm, as it's a compacting algorithm, is basically completely immune to fragmentation.
So if I simplify all this in what I understood, you wrote your own programming language with Zepto4.
Yes.
Okay. And from what I looked at, it was mostly text. Okay, but does it remain? It still is interactive.
Yes, it is.
You could end. It is okay. So I was just wondering if it was a kind of compiled text, but it's really interactive.
It compiles just like any Forth does. It actually uses the Zepto Forth compiler underneath it all, rather than going and implementing a new compiler from scratch.
Okay. So you clarified quite a few points for me. Thanks a lot, Travis.
No problem.
Yeah, thank you very much. And are there additional questions?
I have two questions, Ulrich.
Go ahead. Yeah.
My first question, I guess, is, so this seems like quite a useful addition in terms of if you want to do sort of high level work. How do the rest of humanity learn about Zeptoscript? I mean, effectively, I mean, in a lot of ways, it's got similarities to Forth, but it's got lots of differences as well. Have you got any plans to do some sort of guides, quick start guides, and a programming course or something? How are you going to tackle? I mean, I know that this is sort of, some of it's still fluid, so it's always tricky doing documentation when it's still fluid. I guess my second question is about the interoperation between Zepto Forth and Zeptoscript. So it seems that some problems or some parts of a problem, it's really good to use Forth because it's quite low level, it's quite close to the machine. But other parts of the problem you want to do in Zeptoscript because you've got maybe some complicated memory management. I mean, if you've got networking is often, when you've got complicated networking like a web server or something, doing it it's possible to do it in Forth, but managing that sort of memory and all that sort of stuff can get tricky. So it seems like there'd be a bunch of applications where you'd want low-level primitives in Forth and sort of high-level stuff written in Zeptoscript. Those are my two questions.
Yes, you can do that.
Okay.
The first question, I've written documentation for it, and I wrote a few wiki pages for it on the Zeptoscript GitHub. And that should, the wiki pages really cover a lot of material regarding it. And as for the second question, yes, you can go in and write code that you can call from in Zepto Forth from Zeptoscript. And I already do that quite heavily. Like, for instance, I'd say execute this. The layer for implementing the underlying media for the file system here is implemented in Zepto-Forth. And then I call it from Zeptoscript. So yeah, you can definitely construct parts of your program in Zepto-Forth and then call them from Zeptoscript. The only gotcha is that you have to be careful. You can't really call from Zepto. You can't go the opposite direction very easily and call Zeptoscript from Zepto-Forth, because even though in many cases it's safe, it's not 100% safe, because the garbage collector for Zeptoscript it examines the contents of both the data and return stacks, and it goes and sees, are there any pointers into the heap space of Zeptoscript? And if there are, which basically in this case is there any values that are cell aligned within a specified address range, it assumes that they are indeed allocated blocks of memory within the heap. If they are not, then bad things happen. Any more questions?
Okay, that doesn't seem to be the case. So Travis, thank you again for the great talk, and definitely we should look at Zeptoscript and see what additional features we can explore. Thank you very much. So today is the day of dream machines. I don't know whether you